Hello class. In this video, we are going to review for the midterm exam. The midterm exam has 25 questions. This review has 40 questions for us to practice. Now let's get started. The first question, the cost of sending a large envelope via first class mail is 85 cents. In ounces, then P of X is the cost of mailing it, where P of X equals 85 cents if X is bigger than 0, less than or equal to 1. The cost is $1.02 if X is bigger than 1 and less than or equal to 2, and so on, up through 13 ounces. The graph of P is shown to the right, using the graph to find each of the following limits if it exists. The more important is to understand the graph on the right. We have a piecewise function. This is a piecewise function. The first part, we need to select the correct choice below, and if necessary, fill in the answer box to complete your choice. This part is about the limit of the function, of this piecewise function, when x approaches 3 on the left. Okay. One thing I want to point out is the limit of a function is about the variable y. And knowing the variable y, value of y is on the y-axis. The value of variable x is on the x-axis. Of course, variable y depends on variable x. That's the reason we need to consider how x changes here. X approaches 3 on the left. So when x approaches 3 on the left, we can start from 2, right? And let x approaches 3. Since the y value depends on x value, when x approaches 3 from the left, the y value approaches to what? 1.19. 1.19. So that's the limit. Okay, continue. We have another part. Select the same function. Select the correct choice below. Fill in the same thing. So this one also a one-sided limit. The same function. This time we are going to let x approaches 3 on the right. This is 3. When x approaches 3 on the right side of 3 to the right side of 3, and we can see the y value approaches to 1.36, right? We're gonna have a limit of 1.36. Continue. So the part 3 is about the limit of the function, the piecewise function, when x approaches 3. This limit only exists when the two one-sided limits exist and equal to each other. Obviously, the two-sided limits, they are not each other. They do not equal to each other, right? They both exist, but they are not equal. So we choose B. The limit does not exist. So that's the first question. Second question. Consider the learning curve defined in the graph. Depicted is the accuracy P expressed as a percentage in performing a series of short tasks versus the accumulated amount of time spent practicing the tasks. T, find each limit if it exists. Okay, so we are going to find those 3 limits. The first one is the limit of the function when x approaches 40 on the left. Where's the 40? Okay, we're going to scroll down. Put this down a little bit. This is a 40, right? When x approaches 40 on the left, y value, again, the limit is the value the variable y approaches to that is 40. So the first limit is 40. And from the right, as you can see, when x approaches 40 on the right, y value approaches to 100. So the second limit is supposed to be 100. And the third limit, the same reason with the previous problem, does not exist. Because in order for this function has a limit when x approaches 40, those two one-sided limits have to both exist and equal to each other. Even they are both exist, they are not equal to each other. So we're going to choose D, right? So that's the second question. Question number 3, use the graph of h shown to the right to find the limit. When necessary, state that the limit that does not exist. H of x is this piecewise function. We are looking for the limit of the function when x approaches -3. Where's -3? -3 right here, between -2 and -4, right? As you can see, the limit exists because both two-sided limits exist and equal to 1. Again, the limit is the value of y, the value that variable y approach is 1. Okay, is 1. This is the origin, this is 2, this is 1. And we're going to choose this one and put a 1 here. If the limit of the function exists or not, or the value of the limit has nothing to do with if the function is well-defined at that point or continuous at that point. Question number 4. Same question, I think. The same graph, seems the same graph, or very similar. This time we're looking for the limit of the function when x approaches 0. The origin is right here. As you can see, at 0, the function has a gap, right? On the left, the limit is going to be 5. When x approaches 0 on the right, the limit is 2. So the limit does not exist. Question number 5. Use the theorem on limits of rational functions to find the limit. If necessary, state that the limit does not exist. Okay, I'm gonna have to do some scratch. I'm gonna have to do some writing on my notes. Knowing when x approaches to 4, the denominator approaches to 0, the numerator also approaches to 0, right? And we cannot find the limit this way. So we have to simplify the function here. The denominator is x minus 4. The numerator is a difference of two squares, which can be factored as x minus 4 times x plus 4. And the x minus 4 can be cancelled. And we have limits, x approaches 4, x plus 4. And now we can plug in, right? When x approaches 4, x plus 4 approaches to 4 plus 4, which is 8. Let's go back. Question number 6. Compute this limit. Okay. There are multiple ways to find the value of the limit. One way we can apply is to rewrite the function. What we can do is to divide all the terms in a quotient in this function by x. So we have 5x We have 5x divided by x over x, and 3 over x divided 6x by x, 93 over x. And we can cancel x here, cancel x here, and the function becomes 5 plus 3 over x. On the bottom, we have 6 minus 3 over x. We know when x approaches infinity, 1 over x approaches 0. The limit is 0. So when x approaches infinity, numerator approaches to 5 plus 0. Denominator is 6 minus 0. So the limit is 5 over 6. But if I enter 5 over 6 here, I'm not gonna get the point, because very important. There is an instruction in the parentheses. The question specifies you to type an integer or decimal rounded to the nearest thousandth as needed. If I type a fraction, it won't count it as right. We have to convert it to its equivalent decimal and keep 3 decimal places. What is the value again? 5 or 6. So we can use a calculator, right? Or I can quickly figure out what is 5 divided by 6. So it's 0.833. Is it? Hold on. 0.833. So be very careful. Pay attention to the details. Question number 7, finding the limit. We can use the same strategy, but knowing for rational function is a quotient of 2 polynomials. Means the numerator is a polynomial, denominator is also a polynomial. So when the denominator has a higher degree than the numerator, and when x approaches infinity, the function has the limit 0. That's one way to get it done, or we can use the method that we did earlier. Among the 4 terms in the rational function, the term with the highest degree is x to the power of 3. So what we can do is we're going to divide all the terms in the function by x cubed. So x squared divided by x cubed plus 10 over x cubed on the bottom, x cubed over x cubed plus 16 divided by x cubed, and then simplify. X approaches infinity. X squared over x cubed, that is 1 over x, right? And then plus 10 over x cubed. And here's a 1. They cancel, and then plus 16 over x cubed. When x approaches infinity, this part approaches to 0. This part also approaches to 0 because the numerator is a constant. The denominator approaches infinity. That makes the quotient approach to 0. And this part also approaches to 0. But on the bottom, the first term is 1, remain as 1. So the limit is going to be 0 plus 0 over 1 plus 0, which is 0 over 1, and it's 0. Okay? Numerator is okay to be 0, as long as the denominator is not 0. Denominator is 1. So 0 divided by 1 is 0. Let me just double check. I have the recording going on. Okay, let's go back. Question number 8. Use the graph to find the following limits and the function value. The function is piecewise I probably have to make it bigger. So this is the origin. This is 1. This is 2. So when x approaches 2, from the left side of the 2, on the left, the function approaches to 2. Okay, so we can enter 2 here. When x approaches to 2, this is 2. On the right, the y approaches to, I think it's -1. -1. -1. Since the two one-sided limits are not equal to each other, per C, this limit does not exist. Per D, what's the value of f of 2? This is a 2, f of 2 is a 2. Because this is a circle. That means when x equals 2, y equals 2, because here is a solid dot. Question number 9. We have a function here, and we need to consider the limit of the function when x approaches 4. It's right here. This is the 4. The limit exists when x approaches 4 from both sides. The variable y approaches to, that is -2. Part B, select the correct choice below. Okay, what is a k of 4? Make it bigger. It seems the curve for the function has a hole at 4. I don't see other points. So the function is not defined at 4. Does not exist, is undefined. Question number, we'll continue. Part C, okay. Is k continuous as a 4? Of course not. Just think about what does that mean, continuous. A function is continuous if the function's curve has no any disconnection. Obviously, the curve has a hole here, then the function is not continuous at this point. Question number 10. We are given a piecewise function, and we are told the function is continuous at 3. If is the function, oh, sorry, my bad. So it's asking if the function continuous at 3 or not. Okay. So let me show you how do we determine if a function continuous at a point or not. For this function f of x, if this limit when x approaches 3 on the left, and this one-sided limit when x approaches 3 on the right, and f of 3, when those three things all exist and equal to each other, they're all equal, then we can say the function is continuous at 3. So let's find out. If x approaches 3 on the left, the function of the f has to use the first piece, because when x is less than or equal to 3, the function is 1/3 of x plus 9. When x approaches 3, we can plug in because 1/3 times 3 is 1, and plus 9 is 10. So the first one-sided limit when x approaches 3 on the left, the limit is 10. What about the second one-sided limit approach from the right. Then we're going to use the second piece, 5x plus 3. 5 times 3 is 15. 15 plus 3 is 18. Obviously, let me double check very quickly. Minus 3, my bad. Minus 3. 5x minus 3, so 15 minus 3 is 12. Let me double check this one. 3 is 1, 1 plus 9 is 10. And this one, 315 minus 3 is 12. Okay, we don't have to continue. We know it's not continuous, okay? We don't even have to figure out what's the value of f at 3. It's not continuous. The given function is not continuous at 3 because the limit is not continuous. Because the limit does not exist, okay? Next, question number 11. The graph shows the total sales in thousands of dollars from the distribution of X thousand catalogs. Find the average rate of change of sales with respect to the number of catalogs distributed for the change in 10 to 30,000 catalogs. So this is about the average rate of change. The function here is a sales function. The interval we concern is from 10 to 30. Okay, I probably need to copy paste the graph. Knowing the interval, remember the interval is from 10 to 30. Let's say the function is f. The average rate of change of the function over the interval 10 to 30 is defined as f of 30 minus f of 10 all over 30 minus 10. It's actually the slope. So which one is it? Which point has x coordinate 10 is this one, right? And then 30 is that 3? Is that 30? 10, 20, this has to be 30. This is 40, and that is 50. Okay. So basically, we're looking for the slope of the line passing through those 2 points. And then from the graph, we know what's the f of 30. The function, the value of the function is the y value. It is, I think that's 60, okay? Minus f of 10 is 40. Basically, the second component in the ordered pair. So 60 minus 40. Denominator is 30 minus 10. Numerator 60 minus 40 is 20. 30 minus 10, denominator is 20. So the slope is 1, right? And that's also the value of the average rate of change of the function over the interval 10 to 30. Let me just double check. 60 over 40, 20. 30 minus 10, 20 is 1. Choose this one. Question number 12. The graph shows the median weight of girls between the ages of 0 and 24 months. Use the graph to find the average growth rate of a typical girl during the first year. You know, this actually is a very important information during the first year of her life. If you don't pay attention to this piece of information, you might end up with the wrong answer, because the graph gives from 0 to 2 years old, 24 months, 2 years old, but we only need to consider from 0 to 12 months, okay, from 0 to 12 months. Average rate of change. Let me copy paste the graph here. 0 is here, 1 year old, 12 months is right here. And as you can see, the y value is about equal to, that's 21, let's say, 21. And use that to minus the y value of this red point, this point, now it's red, 8 over 12 minus 0. So average rate of change, just think about the baby was born with as like around 8 pounds, and after 12 months the baby's weight is 21 pounds, right? And the baby has grown how many pounds? 21 minus 8, 13 pounds. Over the 12 months the baby has grown 13 pounds. Then what's the average rate of growth of the baby, right? So 13 divided by 12. 13 divided by 12 is bigger than 1. Not much bigger, but a little bit bigger. Since the multiple choice question, it's going to be this one, okay? Or I can just show you the value 13 divided by 12. Yeah, around 1.1. We choose this one. Every month, averagely speaking, every month the baby will grow like 1.1 pound. Next question. Question number 13. Find the derivative. Find the derivative of the function at x equals -1. Okay. In my guided note, I specify there are two formulas. Of course, there are two specific derivative you need to memorize. The first one is the derivative of root x is 1 over 2 root x. The second one is the derivative of 1 over x is negative 1 over x squared. You need to memorize those two formulas, and it will benefit you. This one is a reason you need to remember the two formulas. This one is the application of the second formula, by the way. So we need to firstly find the derivative. F of x is 8 times 1 over x, right? 8 over x is 8 times 1 over x. And we can keep the 8 and then take the derivative of 1 over x, which is negative 1 over x squared. And that is negative 8 over x squared. And the derivative of the function at x equals -1, which is need plugging in x equals -1 here, right? So negative 8 over plugging x equals -1. Knowing square of -1 is -1 times -1 still positive. So we have a negative 8 over positive 1, which is -8. This one, C. Question number 14. Find an equation for the line tangent to the graph of the given function at the indicated point. You probably have seen this problem a lot. This type of problem a lot. It's a very typical problem in derivative calculus. Firstly, we're going to find the derivative of the function x squared plus 4. The derivative of x squared is 2x. The derivative of 4 is 0. We don't have to plus 0, so it's just 2x. And f of the derivative of the function at -3, knowing the ordered pair, the point here, x value is -3, y value is 13. So let's plug in -3, 2 times -3, -6. And this value, -6, the derivative of the function at -3 is the slope of the equation we are looking for, okay? Now we are going to suppose that y equals mx plus b as the equation we're looking for. Then we found the slope already, right? The slope is -6, that is 6x plus b. If we can figure out the value of b, then we have the equation. How do we find the value of b? We can plug in the point. Since the point is on the curve, also on the tangent line, so this ordered pair should satisfy the equation. So if we're plugging in x equals -3, y equals 13, we should have an equation. So y is 13. On the right side, -6 times x value. The value of x is -3 and plus b. 13 equals -6 times -3, 18 plus b. And then we minus 18 minus 18. We have b equals -5. Okay, so we now have the value for b, the equation of the line, tangent line of the graph at this point is y equals -6x minus 5. That's the result. 6x minus 5. Well, it's a multiple choice question. You know, if it's a multiple choice question, you probably do not have to go through the process. You can totally apply the method of elimination. Of course, you still have to figure out the slope is -6, right? Once you know slope is -6, a is out. And then you can just plug in -3, 13 to see which one would give you a true statement, right? But I probably will not save too much time. And you do need to know the process. Question number 15. Find an equation of the line. Find an equation for the line tangent to same thing, right? Same with earlier. Okay, so let me copy paste. Do it again, same type of problem. Did I mention this derivative is very important? And we see it again, right? F prime of x, the derivative is -36x squared. Plug in the x value of the point 3, positive. We have -36 over 3 squared, -36 over 9, which is 94. So the slope is 94. And you look at the slope has to be 94, okay? So a is out, right? A is out. And d is out because when you're plugging in 3 here, y is a -12. That doesn't work. And if you're plugging in 3 here in C, 94 times 3 is -12. -12 plus 24 is a +12. You can also check the answer choices, use the method of elimination, and C is the answer. Question number 16 is also about derivative, and the function here is a constant function. We need to know the derivative of a constant function is 0. Because we know constant function is a horizontal straight line. And derivative is actually the slope, right? Slope of the tangent line at that point. So horizontal line has slope everywhere. So the derivative is 0 everywhere. Question number 17. We are given an equation. We are given a function. Okay, find the derivative. This one is not difficult. We just need to apply the power rule, right? The first term of the original function is a constant. The derivative of this part is going to be 0. Okay, and the derivative of this part, the derivative of x cubed is 3x squared. I hope you know the formula here. Power rule, xn, power function x to the power of n, the derivative of it is n times x to the power of n minus 1, right? So we have x cubed. The derivative is going to be 3x, 3 minus 1 is 3x squared. And we have a -3 in front of it. So -9x squared. Right here, this one, D. That one is pretty straightforward. Find the derivative. Okay, this might take a little time because the function has 3 terms in it. I'm going to mention again, you need to memorize the two formulas. The derivative of 1 over x is negative x squared, negative 1 over x squared. The derivative of root x is 1 over 2 root x. And that really will make your job a lot easier. So let's find the derivative of the function f. Well, actually, this one, we don't really apply this. We would have to firstly rewrite a function. Let me firstly rewrite a function. F of x equals, the first part is 8 times x to the power of negative half. Root x is x to the power of half, but since this is in the denominator, so we have a negative half if we remove the part from the denominator. And the second part is negative 4 times 1 over x. And the last part is 2 times x to the power of negative 4. All right, so we apply the power rule. The derivative, we keep 8, bring the exponent, and then multiply by x to the power of negative half minus 1. We're going to simplify that in the next step. And then minus 4 times, and this part we can use this formula, right? Negative 1 over x squared. And then plus 2 times, bring the exponent in front, x to the power of negative 4 minus 1. Now simplify. 8 times negative half is negative 4. X to the power of negative half minus 1 is negative 3 over 2. And negative times negative is positive. 4 over x squared. 2 times negative 4, negative 8. X, negative 4 minus 1, negative 5. An expression is not simplified if it has a negative exponent. So we would have to put this in the denominator. Get rid of the negative exponent. Become positive here. Same thing here. We move x to the power of 5 to the bottom. And then do we need to rewrite this part as a radical? Is the square root of x cubed plus 4 over x squared minus 8 over x to the power 5th. Is that a multiple choice question? Multiple choice question make it a lot easier, right? You just need to find the one that is the same as your answer. Oh, it doesn't convert to radical form. Keep as the exponential form. So negative 3 halves. Negative 3 halves. Is this one? Negative 4, 4 positive 4, negative 8. Yeah. Question number 19. 2 parts. Part 1. Use the product rule to find the derivative of the given function. Okay. The given function is a multiplication of 2 polynomials, right? You can see this as f, this as g. Do you remember the product rule for derivative? F times g. Take the derivative of f times g. We have f prime times g plus f times g prime. Okay? And in this problem, our f is going to be 4 minus z squared. Our g is going to be the polynomial in the second parentheses. Let's look at our answer choices. Part A makes more sense. Oh, here we have to enter. So 4 minus z squared, here is going to be, in this cell, we're going to have the derivative of the second polynomial. That's going to be 3, a lot of typing, 3z squared. Do not use x. The function is in terms of z. If you type x, because most of the time we use x, right? Of course, you won't get it right. Minus 2. and constant has 0. So that's in the first cell. The second cell is going to be the derivative of the first function. 4 has derivative 0, so -2z, -2z, right? And also be careful. Sometimes you are not once you have this, right? You just randomly click somewhere, but actually you changed your answer. You need to make sure. In this case, I want to choose A, and I really have this dot, this A chosen. Next question, number 19. Oh, not done yet, sorry. Expanded product. Expanded product. Okay, so we're gonna use a distribution problem, repeated distribution method for this one. So first, let's distribute the 4. 4z cubed minus 4 times -2z, -az plus 4. And then we distribute the second term, -z squared. Be careful with the sign. Negative z, 2 plus 3 is a 5. And then negative is a positive, 2z cubed. And then minus z squared. Let me double check. 4 -8 plus 4, negative z fifth plus 2z cubed minus z squared. Okay, let's see, do we have any like terms to combine? This term and this term can be combined. Besides that, except that we don't have other. So the leading term, negative z fifth, and then 4 plus 2 is 6z cubed, and minus z squared minus 8z plus 4. And make sure we have all the terms included. Negative z fifths, 6z cubed minus z squared minus 8z plus 4. We need to enter the whole thing to the cell. You won't have the problem because you're going to have the work on your scratch paper. I just take a picture of the result, then I can see it and then type the answer here. So it's going to be z, negative z, power of 5, 6z cubed plus 6z to the power of 3 minus z squared minus z squared. What is this here? Minus 8z plus 4. Make sure you double, triple check your answer. If you enter anything, if you make any mistake, like a sign or anything, you will waste all the effort, right? And then not done, it's still question number 19, and use either approach, to find the derivative of the original function. Okay, so actually I think since we have the expansion of the product, we can just get a derivative by taking the derivative of this function, right? So negative 5 z to the power of 4. A lot of typing. Negative 5z to the power of 4 plus 18. 6 times 3 is 18. Z squared. Z to the power of 2nd. Negative az, the derivative is negative 8. Ooh, be careful. Minus 8. And that's it. Double check. negative 5z to the power of 4th plus 18z squared minus 2z. Okay, I messed up. Minus 2z, minus 2z. So it's always good to double check. Minus 2z and then minus 8. That's a very long question. Question number 20 is also a product, right? You can see the first function, the function in the first parenthesis as an f. You can ignore this f, okay? You can change that to y. F times g. And I already show you the formula for the product rule right here, right? Use that formula, and let's see which one give the correct. We should not have any denominators, so a and d are out. A and c are out. Between b and d, this one doesn't seem right because, oh, hold on. Oh yeah, this one doesn't seem right. This one seems right. Okay, this one looks scary, this question, but actually it doesn't really require you to do any calculation. It only requires you to know the formula for the product rule. So the first function, take the derivative, multiply with the second function, plus the first function unchanged, multiply with the derivative of the second function. Okay, so it's just the application of the formula. You don't even need to do any work. Question number, oh, I'm sorry, we do need a 2 because it has 2 parts. My bad. Yeah, the derivative of the function is, okay, so let's, how about plus 9x squared times 3x plus 9x squared times negative 8 plus negative 2x times 4x squared plus negative 2x times 3x plus negative 2x times negative 8 plus 2 times 4x squared plus 2 times 3x plus 2 times negative 8. So we have 9 terms here in the expansion. And the first one, 36 x to the power of 4th. And this one, 27 x cubed. And minus 72 x squared. And the second row, negative 8 x cubed. Negative 6 x squared plus 16x. Last row, 8x squared. What is this here? 3, right? X is. So 6x, 2 times 3, 6x, and minus 16. And now we're going to combine like terms. We only have 1x to the power of 4th. We have those 2x cubed. And that is 27 minus 8 gives 19 x cubed. And then for the squared, we have those 3 terms, right? 8 minus 6 is 2, positive 2, and negative 70. Negative 70 x squared. And that is 22x minus 16. 22x minus 16. And then we take the derivative. 36 times 4, 144, x cubed, plus 19 times 3, 57, x cubed, minus 140, x, and plus 22. Yeah, actually it's different from earlier, right? And this method obviously is shorter. Therefore x cubed minus 140x plus 22. Minus 140x plus 22. minus 140x plus 22. Double check. All right, I apologize earlier I messed up the first method. Obviously, the second method is better. We expand the product first and then we take the derivative. And let's continue this number 20. How do I continue here? Number 21. Question number 21. Differentiate. This is a rational function. We're going to use the quotient rule. Okay, we're going to let f be the numerator, g be the denominator. So f is 2x plus 1, g is ax squared plus 1. Then f prime, the derivative of f is going to be just 2. G prime is going to be 16x. All right, and the formula for quotient rule, we know denominator is the square of the denominator, right? Numerator is going to be f prime g minus f g prime. I hope you are very familiar with those formulas. And then we plugging in. Denominator g squared. G is ax squared plus 1 to the power 2. Numerator f prime is 2 times g, ax squared plus 1, minus f 2x plus 1 times g prime, which is 16x. A lot of algebra. Algebra is the foundation of calculus, right? The idea of a calculus, to be honest, I don't think is very difficult to understand. It's actually, for a lot of students, the algebra part is challenging. 16x squared plus 2 minus 32x squared minus 16x. Let me double check. Keep the denominator. Combine the like term in the top. Negative 16x squared minus 16x plus 2. That's the top. Denominator is the square of ax squared plus 1. So let's see which one has the... As you can see, the denominator of all the four answer choices is the same thing, right? So you don't have to worry about the denominator. Mainly the numerator. What we have is negative 16x squared plus minus 16x. Minus 16x. Hold on. Minus 16x minus 16x squared plus 2 minus 32x squared minus 16x. And then they combine those two, negative 16x squared minus 16x plus 2. Let me double check my work. F 2x minus, oh my gosh. There we go. I apologize. Is minus 1. 2x minus 1. 2x minus 1. So here it's going to be minus 1. Okay, and is that fixed? So this is going to be negative 32x squared, but this is going to be positive 16x. Positive. This one, D. Question number 22. Differentiate. This problem we need to use the chain rule. Okay, so we let y be rule u. We're going to let u to be the radicand under the radical. Then u would be 17x minus x to the power 5. dy over du, du is 1 over 2 rule u. I mentioned you need to remember this formula, right? And you are using it now. And du dx, technically we should not say dy over du or du over dx, because this is operator. But for convenient purpose, we can say du dx equals 17 minus 5x to the power 4. 17 minus 5x to the power 4. Okay, so dy dx equals dy du times du dx. We need to multiply the two derivatives, 1 over 2 rule u times 17 minus 5x to the power 4. I'm going to put that in the numerator. And denominator 2 rule u. u is 17x minus x to the power 5. See which one is the same with our answer. The multiple choice question makes it a lot easier, right? Which one is the same? We're going to have a 2 on the bottom. We're going to have a 2 on the bottom, so a is out. And numerator is not 1. It's going to be more complicated than just 1. 17 minus 5x to the power 4. This one, D. Question number 23. Differentiate. Okay, continue. Same with earlier, chain rule. Y equals u to the power 5th. U is 3x plus 3. Yeah, this time let me be careful. We should always be careful. Do not copy anything wrong. All right. dy du, 5u to the power 4th. du dx. I'm going to put that part here, okay? F over g. I'm going to use a quotient rule for u. And here f is the top, 3x plus 3. G is the bottom, x minus 3. F, the derivative of f, just 3. The derivative of g is just 1. And we plug in, denominator is g squared, so x minus 3 to the power of 2. Numerator f prime, 3 times g minus f, 3x plus 3. G prime is 1. F prime is 3, g x minus 3 minus f, 3x plus 3 times g prime is 1. Okay, continue to simplify the top. I can do it here. 3x minus 9 minus 3x minus 3. 3x cancel 3x. Negative 9 minus 3, negative 12 over x minus 3 to the power 2. So du dx is negative 12 over x minus 3 to the power of 2. And then we apply the chain rule. dy dx equals dy du times du dx, negative 12 over x minus 3 to the power 2. U is this complicated, it's not very complicated, I mean the rational function to the power of 4. And then times negative 12 on the top, x minus 3 to the power of 2 on the bottom. We do have to simplify a little bit. 5, 12 is 60. So we have a negative 60 here on the top. We have 3x plus 3 to the power 4 on the top. We have x minus 3 to the power of 6 on the bottom. I hope you see it. Is this a multiple choice question? Okay, make it a lot easier. So we're gonna have a negative 60 this one. It's gonna be this one. Okay. Question number 24. Also differentiate. Okay. This question, would you choose to expand and then take the derivative? It could do that. You could do that for sure. But you need to know the formula, or you have to FOIL multiple times to get it done. I'm going to use the product rule. F is x, g is x to the power 5th plus 5 to the power 3. So this function times this function. The first function is just very simple. The second function is a little bit more complicated. F prime is 1. G prime is, use chain rule, 3 times x to the power 5 plus 5 to the power 2, and then times 5x to the power 4 plus 0. Okay? And then simplify g prime a little bit. 15x to the power 4th, x 5th plus 5 to the power 2. So that is g prime. And the dy dx, use the product rule is going to be f prime g plus f g prime. F prime g is 1. F prime is 1. G is this function plus f is x. G prime is 15x to the power 4th, x 5th plus 5 to the power 2. Simplify. X 5th plus 5 to the power 3 plus 15x to the power 5th, x 5th plus 5 to the power 2. Do we need a factorization? Let's see, depends on the answer choices. Oh, we have to type. Okay, so we would have to factor x to the power 5 plus 5 to the power 2 out. Then we have x to the 5 plus 5, and then plus 15x to the power 5. Simplify the bracket. X 5th plus 5 square. In the bracket, we have 16x to the power 5th plus 5. We can change the bracket to parentheses. Okay. Okay, so I think this should be good enough. X 5th plus 5, and raise the parentheses to the power of 2. Inside the second parentheses, we have 16x to the power of 5 and then plus 5. I hope it's correct. Very good. Next, 25. Find the dy du dx and the dy dx. This is a chain rule. Okay, so let's process on the note. Oh, okay, sorry. This is probably have 3 parts. So the first part asks you dy du. We can just do that here. It's a very simple power function. 52 times u to the power of 51. That's the first part. Second part, du dx is also not difficult. 10x to the power of 4th. 10x to the power of 4th, and then minus 9x squared. And then you're going to multiply them together. You have 52 and in the parentheses. Inside the parentheses, we have u, which is 2, a lot of typing, x 5 minus 3 x cubed. Double check to the power of 51. And then multiply with du dx, and use another parentheses. Put it in 10x to the power of 4th minus 9x squared. Two x fifth minus 3x cubed, 51. Next, question number 26. Find the second derivative. Okay, find the second derivative. Let's work on that on the note. This notation means the second derivative. We can also use two double primes to represent the second derivative. We're gonna have to find the first derivative first. 2x plus 1 over 2x squared. This is not the first time we use this formula, right? Trust me, this really will worth your time to memorize. And then we have to take the second derivative to make that easier for us. And we would have to redo this one. It's half x negative half. Well, maybe you don't use this formula. You can use the power rule for this specific problem. Half minus 1, so half x to the power negative half, because we want a function in the exponential form. If it only requires the first derivative, then you are done, right? But since we have to take the derivative again, we would like to have the function, any part of function in the exponential form. Now, second derivative is 2. And here we keep half and bring down negative half. X to the power negative half minus 1. 2 minus a quarter. X to the power negative 3 over 2. Yeah, we need to get rid of the negative exponent, write x to the power 3 over 2 on the bottom. This is the, so we have 2 minus, oh. So the answer choice is give 1 quotient. We would have to keep going to simplify, rewrite a form. So we're going to write 2 as 2 over 1. And then multiply both top and the bottom by 4x 3 over 2, 4x 3 over 2. Then we have 8x 3 over 2 over 4x 3 over 2 minus 1 over 4x 3 over 2. And now they have the same denominators. Solve the top. 8x 3 over 2 minus 1. That's the same with mine. Next, question number 27. Third derivative. Okay, let's do it. Okay, let me just quickly check. I am recording. This means I'm recording and I'm not muted. Sometimes a nightmare when I find out something went wrong in the middle of recording. Let's go back to note. F is 1 over x plus 1. First derivative. You know this is you can use a chain rule, right? Or if you're familiar with this type of function, you know you can see this as u. And 1 over u, the derivative of 1 over u is negative 1 over u squared. We have seen that. We have used this a lot of times in the review. Negative 1 over u squared, and then multiplied by the derivative of x plus 1. Actually, is 1, right? So the first derivative is just a negative 1 over x plus 1 to the power 2. To make the next step easier, we're going to write this expression as a negative x plus 1 to the power of negative 2. And second derivative, we use the chain rule, keep the negative sign, and bring down negative 2, and x plus 1 to the power of negative 2 minus 1, and then multiply by 1. 1 here is the derivative of the inside function x plus 1. Of course, you don't have to write it. It's multiplicative identity. To simplify, negative is a positive, and x plus 1 to the power of negative 3. So that's the second derivative. We need to find the third derivative. 1, 2, 3. And do the same thing. Keep 2, bring down negative 3, x plus 1 to the power of negative 3 minus 1, and then times the derivative of the inside function, which is 1. 2 times negative 3, negative 6, x plus 1 to the power of negative 4. And the answer should be negative 6 over x plus 1 to the power of positive 4 on the bottom. Okay, so we do not need this one, just this one, okay? Technically, the answer is supposed to be the one on the bottom because an expression with a negative exponent is not seen as simplified. But this is just a multiple choice question. We have negative 6, negative 4. Question number 28. If s is a distance function, find the acceleration function. Okay. We know that velocity function is the first derivative of the position function. The acceleration function is the second derivative of the position function. So basically, we are looking for the second derivative of this function. So s prime, which is v of t, velocity function, is 8t cubed plus 21t squared plus 4. And the acceleration function is second derivative of the position function. So we're going to do that again. 24t squared plus 42t plus 0. We don't have to write 0. And that's it. 24t squared plus 42t. 24t squared plus 42t. Double check, is that the same way as that? 24, 42, t squared t, this one. Question number 29. Differentiate derivative of a exponential function. As you can see, for midterm, majority of the problems are about differentiation. You need to memorize those formulas very well. Y prime is, let's do chain rule. Let's let y be e to the power of u, and u as 6 minus 7x. dy du is e to the power of u, right? du dx is -7. Then dy dx is multiply those two functions together, e to the power of u times -7, which is -7 e to the power of u. What is u? 6 minus 7x. Not too bad. -7, well, I have to, there's multiple choice question. -7 e to the power, this one, c. Question number 30. Find the derivative of the function. This is a natural logarithmic function. We can use the chain rule again. We can let y be ln u. U is 9x cubed minus x squared. dy du is 1 over u. du dx is 27x squared minus 2x squared. By the chain rule, dy dx is, this is u, sorry, is this times this, right? So I'm gonna put that on the top because we're multiplying, and the numerator of 1 over u is 1. And u is going to be on the bottom, which is 9x cubed minus x squared. Yeah, since x is not equal to 0, it's positive to make the function well defined. So we can get rid of x squared here. 27, hold on. 20, too fast. du dx, 27x squared minus 2. Why do I have this? No, just 2x. 27x squared minus 2x over u. U is 9x cubed minus squared. Okay, we can get rid of 1x. So 27x minus 2. 9x squared minus x. All right? 27x minus 2. 27x minus 2. 9x squared minus x. Is this one? I think. Question number 31. Solve the exponential equation. Round to 3 decimal places as needed. This actually is a pre-cal problem. We know we have 2 different methods for exponential equation, right? This one, we're going to apply the second method, take ln on each side. Then we would have ln e 0.04t equals ln 9. And by the power rule, I hope you still remember what is the power rule. Power rule tells us we can bring the exponent in the argument in front of the log. Hope you still remember that. So we can bring 0.04t in front of ln e. And then we left ln 9. ln e is 1, by the way, because the base and the argument are identical. So I have 0.04t equals ln 9 divided each side by 0.04. T equals ln 9 over 0.04. But we have to convert it to decimal, right? So you do need a TID for calculator. I'm not sure a scientific calculator can do this, but you're allowed to bring an 84, so why not? What is it? ln 9 over ln 9 divided by 0.04. keep how many decimal places? Oh, it's a multiple choice question. 3 decimal places. 931. 54, this one. Question number 32. Solve the equation. This is a logarithmic equation. Okay, so we can condense the left side, right? Condense the left side. LG with base 3 by using the product rule. You remember product rule? When you add 2 log with the same base, and you can keep the base and multiply the 2 arguments. And we're going to do this here. Apply the product rule here. X plus 2 times x minus 4 and equals 3, right? And then we are going to convert this equation to its equivalent exponential equation. So we're going to have the base is 3 to the power of 3, this logarithm, equals the argument x plus 2 times x minus 4. X plus 2 times x minus 4. This is also a pre-calc problem. Cube of 3 is 27. And we have to FOIL, and we expanded the product, x squared minus 2x minus 8 equals 27. And then minus 27 from each side. X squared minus 2x minus 35 equals 0. And then we have to factor the left side. Let's try 5 and 7. -7 positive 5, -35, -7 plus 5, -2. Okay, so x either equals -5 or x equals positive 7, but not done yet. When we solve logarithmic function, we have to, very important, check the proposed solution. In this case, yeah, 95 is not a solution because 95 will make the argument be negative, right? 95 minus 4 is a negative number. 95 plus 2 also negative, so 7 is fine. So the answer is 7. I give you the whole process of solving the equation, but the problem is a multiple choice question, so I do not mind you use the method of elimination. You only have 7, 8, 95, 95. I only have 7, 8, 95, right? When you plug in 95, you can see 95 is not in the domain of the equation, so C is out, D is out. And then you can try to plug in 8. It will not make the equation be a true statement, so you can choose 7. I'm just saying it's a strategy. If it's a free response question, you need the process, right? But I don't mind you use a strategy when the problem is a multiple choice question. Differentiate. The function f has 2 parts. The first part is a power function. The second part is an exponential function. Okay. F prime. Let me look at the requirement one more time. Yeah, just to take the derivative. 5x to the power 4 minus 9 e to the power 3x times 3. Okay. E to the power kx to the power e to the power kx. The derivative of the function is k e kx. So the derivative of e 3x as the exponent is 3e 3x. Simplify 5x to the power 4 minus 27e to the power 3x. We're going to enter that to the cell. 5x 4 minus 27 e to the power of 3x. Double check the entry. 5x to the power 4th minus 27e to the power of 3x. Okay. Question number 34. Differentiate. Okay. You can use a chain rule, right? E to the power u, is gonna be e to the power. Derivative is gonna be e to the power u also, and u is x squared. Be careful the entry. Hold on. X squared plus 7x. That's the outside function. That's the derivative of the outside function. By the chain rule, we have to multiply the derivative of the inside function. The inside function is x squared plus 7x, whose derivative is 2x plus 7. 2x plus 7. Right? You can bring it down. You can write y equals e to the power u, u equals x squared plus 7x, and use the chain rule. Question number 35. Okay, so we are going to use product rule for this one. We're gonna let y be f times g. F is the trinomial in the parentheses. Be very careful. I think sometimes since I'm right now have to multitask, have to talk and then write, right? So be very careful. X squared minus, when you don't have to talk, just write probably have less chance to make mistake. And g is e to the power x. F prime is 2x minus 2. G prime is e to the power x. And y prime by the product rule is f prime g plus f g prime. Plugging in. F prime g, f prime 2x minus 2 g e to the power x plus f x squared minus 2x plus 9 y prime e to the power x. Okay, and as you can see, they both have factor e to the power x. We can factor it out and then add the rest of the power together, 2x minus 2 plus x squared minus 2x plus 9. Combine like terms. 2x cancel negative 2x. We have x squared plus 7. 9 minus 2 is 7. So that's going to be the answer. X squared plus 7, this one. Question number 36. Differentiate again. Okay, this one actually is a pretty, I cannot say easy, but not that complicated. 3, the bottom is going to be, because ln u, right? Outside function is ln u, the derivative is 1 over u. So you're going to be on the denominator. X squared minus 5x plus 1. And the numerator is going to be the derivative of the inside function. Inside function is the trinomial in the parentheses. And numerator is going to be the derivative of the trinomial. 6x minus 5. Find the derivative of the function, okay? This one actually is similar with the previous problem. How about this one? Let me show you the work. Use the chain rule. We have outside function y equals ln u. Inside function u equals 2x squared. Dy du 1 over u, du dx 4x. And dy dx by the chain rule is dy du times du dx is 1 over u times 4x. 1 over u is 2x squared. 1 over u times 4x. So we have 4x on the top, 2x squared on the bottom, and cancel 1x, we have 1x on the bottom, so 4 over 2 is 2. So 2 over x. 2 over x. 8. Question number 38. Derivative. We would need to use the quotient rule for this problem. Numerator f, denominator g, f ln x, g x to the power 6, f prime 1 over x, g prime 6x to the power 5th, and dy dx is f over g derivative. So the formula, remember the formula for quotient rule, f prime g minus f g prime all over g squared. G squared x to the power 6 to the power 2. Numerator f prime times g minus f times g prime, 6x to the power 5th. Simplify, we're going to have x to the power 5th here, minus 6x to the power 5th ln x. On the bottom, we have x to the power 12. We know the power rule, right? Multiply the two exponents. 6 times 2 is 12. And all three parts have x to the power 5 as a common factor. So I mentioned this in the class. Left ear, right ear, and head, right? Only when all the three parts of the Mickey Mouse has a common factor, we can figure it out. So x is not equal to 0 anyway. It's actually bigger than 0 to make the function well-defined. So it's okay, we divide by x to the power 5th is 1 minus 6 ln x over x to the power 7. 12 minus 5 is 7. So that's the answer. 1 minus 6 ln x. 1 minus 6 ln x. This one. Question number 39. Management at a factory has found that the maximum number of units a worker can produce in a week is given by P of t equals 50, this function. It's, where t is the number of weeks the worker has on the job. So basically t represents the experience of the worker. How many units can a worker produce in a week after being on a job for 8 weeks? It's an application problem, but not that complicated because you only need to understand the meaning of the input variable and output variable, and then know how to do the algebra, since you need a plugging in. Sometimes an application problem takes multiple try to understand what's going on in the problem. It's totally normal. Do not rush to do anything. For a word problem, you'll see a lot of words. That means you need to take your time to read those words. T here is 8 weeks, right? So we're going to plug in t equals 8. Then P of 8 equals 53. 1 minus e to the power negative 0.5 times 8. We can simplify a little bit before using the calculator. 53. 1 minus e to the power of negative 4. Half of 8 is 4. Like that. we would have to use the calculator. 53 times the parentheses 1 minus e to the power of -1, knowing this is the negative sign. Okay, if you use TI-84 calculator, you need to know how to use it. This is the negative sign. This is the minus sign. Minus sign. You cannot confuse one with the other. Negative, what is it? 4, right? -4. And then complete, close the parentheses, double check. 53, 1 minus e to the power -4. Okay. How do we run it? Round to the nearest is integer, so 52 units. Question number 40, the last one. The size of a certain insect population is given by P of t. So this is a exponential growth problem, where t is measured in days. At what time will the population equal 1500? So we need to understand the meaning of those variables. E here is not a variable. E here is a constant. Is the Euler number around equal to 2.7, right? T is a variable. T is the time in days. P of t, P here is a variable, dependent variable. The population, P is the population of the insect. So we want to know time such that the population is 1500. So we know, I'm going to copy the formula here, the equation here. And then plugging in P equals 1500. Plugging in, this is not supposed to be here, okay? Plugging in P equals 1500 and then solve for T. P is 1500 on the left side, 300 e to the power 0.02 t, right? And then divide each side by 300, and they cancel. On the right side, you have e to the power 0.02 t. On the left side, you have 5, 1500 divided by 300, 5. And then we use natural log. We have ln 5 on the left side. We have 0.02 t ln e on the right side. This step, we apply the power rule, right? Power rule. In the argument, we can bring it in front of the log. And we know ln e is 1. So we have ln 5 equals 0.02 t. Divide each side by 0.02. We have t equals ln 5 over 0.02. ln 5 over 0.02. How many days? 81 days. Round to 1 decimal places. 1 decimal places. This is also important. The rounding rule, the rounding instruction. 1 decimal places. So 80.5. 80 and a half days. 80.5. 80.5. Okay, so that's all the questions. That's all the questions. I hope the video helped you. If you have any questions, feel free to email me. I'll see you in the video that we review for final.